Now let's talk about JSON Web Tokens. Okay, let's see. A JSON Web Token, or a JWT, is a JSON-based open standard for creating tokens that shares some numbers of claims. You can learn all about this technology in wut.io website, but in a nutshell, this type of token is comprised of three sections separated by a dot in the format A, B, and C, as you can see in the picture showing you in front of the screen. B is the payload. Okay, this is where you put the data and the claims. C is the signature, which is used to verify the validity of the token, and A is the algorithm used to compute signature. A, B, and C are all encoded in a URL safe base64 encoding. This encoding strategy, base64, is a popular binary to text encoding scheme that represents binary data in ASCII string format by translating it into a radix 64 representation. The radix 64 representation uses the letters A to C in uppercase, and also A to C in lowercase, and the digits 0 to 9, plus the two symbols plus and division sign, for a grand total of 64 symbols altogether. Therefore, not surprisingly, the base 64 alphabet is made up of these 64 symbols. Base 64 is used, for example, to encode images attached in an email. It happens similarly, so the vast majority of people are completely oblivious of this fact. The reason why JWT is encoded using base64 URL is because of the characters plus and the division sign symbol, because which in a URL context means space and path separator respectively. Therefore, in the URL safe version, they are replaced by dashboard and underscore. Moreover, any padding character like equal, which is normally used in base64, is stripped out, and this too has a specific meaning within the URL. The way this type of token works and therefore is slightly different than we are used to when we work with hashes. In fact, the information the token carries is always visible. You just need to encode A and B to get the algorithm and the payload. However, the security lies in part C, which is HMAC hash of the token. If you try to modify the B part by editing the payload, encoding it back to base64, and replacing it to the token, the signature won't match anymore, and therefore the token will be invalid. This means that we can build a payload with claims such as logging as an admin or something along those lines, and as long as the token is valid, we know that we can trust that the user is actually logged in as an admin. So let's start with a single example. Okay, in this case, I will create a new file called talk.py. Inside, I will import JWT. Okay, I will say data payload data ID 1 2 3 4 5 6 7 8 9. Okay, then I will say token will be just the JWT encode. I will encode data, and I will specify the key, secret key. Right. Similarly, I will say decode, but in this case I will decode the token data out. You will see token. Okay, now I will print my token and the data out. Okay, I will start new terminal here. I will say chapter 9. I will talk.py. So if it's requiring an algorithm, I can say algorithms HS 256, and you hear your code. Okay, our token, and also we'll have my payload, right? Payload data ID 129. Okay, we define the data payload here. We contain ID and some payload data. Then we create a token using JWT.encode functions, which take at least the payload and the secret key, which is used to compute a signature. The default algorithm used to calculate the token is in this case HS 256. The values are there. So as you can see, the token is in binary string or base 64. You already encode pieces of data. We have called the JWT.decode, providing the correct secret. Had we done otherwise, the decoding could have problem. Sometimes you might want to be able to inspect the content of the token without verifying it. So you can do it simply calling the code in this way. Verify false. But I will separate it, okay? It will be in the other line, and let's say something like this. Okay, and verify data out. Okay, here let's say okay, this is old syntax, and I will try with another option. Adding options, I will say verify signature, and we'll see will be false. Okay, of course there is a comma here. I will try again. Okay, in this case our token, our data, and our data also. But in this case, the verified signature is with a false flag. This is useful, for example, when values in the token payload are needed to recover the secret key, but that technique is quite advanced, so I won't be spending time in this context. Instead, let's see how we can specify the different algorithm for computing the signature. What about if we say token 512, and we say data, and we see secret key also. In this case, algorithms will be H512. Okay, and the single way and the same way will data 312 like this. Token 312 data out. Oh, the algorithm must be the same. Okay, something wrong here. Let's try algorithm like this. You want set it like this. Algorithm. Okay. The problem must be this. I will encode first and then I will decode it, right? Yeah, right. This is an unexpected parameter here in JWT encode function. So let's try again. Okay. We need to specify the algorithm here, okay? Right? Probably not in this way, but you can try it like this, and you will obtain something like that. Okay, you will obtain the data in the token in 200 in H8 512 algorithms, and you will decode it in also algorithm with HS 512. The output is your real payload or a dictionary. In case you want to allow more than one algorithm in the decoding phase, you can even specify a list of them instead of only one. Okay. Now, while you are free to put whatever you want in the token payload, there are some claims that have been standardized, and they enable you to have a great deal of control over the token. These claims are the following. Okay, you will see here EAST, which is the ESS, is the issue of the token. It represents the subject information about the party this token is currently carrying information about. Out, which means the audience for the token. Exp here, the expiration time after which the token is considered to be invalid. MBF, I don't know where is MBF, I can see it, but if you will see it, it represents not before time, on the time before which the token is considered to be not invalid yet. EAT, which is here, EAT, the time at which the token was issued, and also JTI, which can see now in this picture also, but it represents the token ID.